Hey grade 12, welcome to my channel. Let's just have a look at these few questions as requested by one of you. This was the 2009 November paper. Very interesting paper, to be honest. I understand what those students said. We've discussed question 6 alone, so they, or at least let me say, the person who made the request requested 7, 8 and 13. So let's have a look at this. Of course, for you guys in DBE, this would apply for paper 2. But in any case, you know what? Preparation is never early it's never early, but it can be late. And this is almost late if we look at it. Okay, let's just quickly look at these graphs. The graph of f, k equals 3 cos x. But now we see that this cos x is nothing but the basic cos graph. So what are we going to say? Okay, we know that the 3 before this gives us the amplitude. Okay, now the amplitude will give us the maximum value and the minimum value. Maximum would be the 3 because this is not shifted about horizontally or vertically, but mainly vertically. And this is going to be the negative version of it. Okay, and we know that that constitutes the range of our function. Basically, maximum and minimum gives us the range. Then we continue and say this is the cosine graph. Okay, coefficient of the angle x is an invisible one. So what does it mean? It means the period is going to be 360 degrees, the original cosine graph, period divided by 1, which gives us 360 degrees. That's easy. Now, what does this help us with? It helps us to get intervals. Intervals is going to be the period at hand divided by the 4 quadrants in which we draw these graphs to complete a full revolution. This gives us 90 degrees. Now, how does these intervals help us? They help us with what I would call critical values. Now, a critical value could be a y-intercept, could be an x-intercept, it could be a turning point. Now, turning point can be both maximum and minimum. All right, so this is the most important piece of info to really internalize and say, okay, why do we bother with intervals? Because we can actually get the distance between the critical values, meaning from an x-intercept to a y-intercept to a turning point, be it maximum or minimum. That's the essence of really exploring this. Now we move on to the next graph. We see g of x is the sine. Now if we see here, the coefficient of the actual ratio, or whatever you would call it, is essentially an invisible plus 1. So that means the amplitude is going to be 1. That means the maximum here and minimum. Max is going to be that value, minimum is going to be the negative version. Usually the smaller is the minimum, the bigger is the maximum. Even if this was a minus 1, this would still be the case. And then again, that gives us the range of that function. So that is the push towards this. But now there's more in this one. If we look ahead, we'll see that the angle itself is a singleton. So this means the period would be determined the same way as we have just done. And that would also simply means the same intervals would be expected. Not a problem, but we see there's a little bit more too. Okay, what is this next little bit more? We see a minus 60 degrees. Now this is a horizontal translation. Maybe let's just write in short and say horizontal shift to right by 60 degrees, meaning every point if we take any point x, now we will add some 60 degrees and some corresponding y value. Okay, maybe let's just keep it this way. So basically, taking any point, the x value will add 60 degrees and the y value may remain the same. This is essentially the information being given by that piece of information. Okay, now let's have a look. The cosine graph starts at 0, right? Right. And we see this is maximum. So can you see it gives us a critical value at x is equal to 0. And from there we move 90 degrees to the right. Can you see we hit an x-intercept? From there we move 90 degrees to the left, we hit an x-intercept. We move 90 degrees further, we will hit a maximum value. Okay, sorry, a minimum value. Can you see intervals assist in this regard? It helps to know them and to determine them for any graph given or any equation given for that matter, using the period. Now, we're done with the cosine graph. We don't want to complicate this any longer. Let's look at the sine graph. Sine graph would start at 0, but now this has shifted 60 degrees to the right. If we add 60, can you see that would have been at the origin because sine of 0 is 0. But now it ends up at 60, which is 60 degrees ahead of that particular point. Now we know that sine of minus 90 would give us a minimum value of minus 1. But can you see this shifts 30 degrees to, 60 degrees to the right? That goes to minus 30. Okay, and again we would have this at 180, but if we take it 160 degrees ahead, it falls on 120. Now is that a maximum or what? Let's just take maximum should be 1. You can just draw a horizontal line. Can you see it's not quite on the line? Of course, make sure your ruler is perpendicular to the x-axis when you do this. Okay, if you don't know how to do this, you put a protractor here, you mark a 90 degrees and then you draw a line passing through there. If it doesn't intersect here, it means we are not at maximum. Okay, that's very important. So we can't really look at that at this point. Then of course we've got those 2 points of intersection, not a big deal. This is where the two graphs are equal. Can you see once you understand the graph, and of course pay attention to the domain in which this is drawn. This is from from minus 180 degrees to 90 degrees. Now we can try to answer these questions as quickly as we can. So a little bit of a quick revision, but of course guys, don't make it a habit to do this in the actual exam. Do this when you practice. Take time, understand things, so that when you get to the exam, you just go on cruise control. That is truly the way to get around these things. You can't speed up if you don't know. But if you know enough and you are ready enough, you will then be able to speed up. So you guys worry too much about time when you don't already know the knowledge that you need to have. So must contain the knowledge and it must be easy, user-friendly. Then you can work on time. But usually, if you know enough, time automatically falls into place. You can't keep time if you don't know. That's the one thing I can assure you. So be very careful not to focus on the wrong thing. Focus on the right thing. And the right thing is get the knowledge and make it user-friendly. Be able to pull it whenever you need it. Then time can be an issue if you overly do these analysis or analyzes. Meaning you need to do this in your head mostly, or at least understand these implications. I'm doing this to highlight this to a student who's still struggling with this section, but those that know it, they wouldn't even think twice about what is cooking here. So that means those ones who already know this, second nature, they can just easily answer these questions, even less than half of the time that this probably would suggest. Say 8 marks, maybe you would want to say 8 minutes, but you can do this in 4, right? Right, now let's answer these questions. It says write down the range. Can you see? Write down the range of f. What did we just do? We dispelled it right there. So we can just say range is equal to a set of y values such that y is less than or equal to the maximum, greater than or equal to the minimum. I just like this way, but it's not unique. Another student can write y is an element of -3, the minimum, all the way to 3, the maximum. Put square brackets to include those values. Again, that would still be 1 mark. So another student may say, look, I just want to write like this and nothing else. That is still okay. Don't know what is this dude doing there. So that is still okay. So any one of these techniques is enough for just 1 mark. 7.2 says if A is minus 97.37 degrees is to minus 0.38. Okay, now we're focusing on point A. Okay, now we are to write down the coordinates of B. So now this uses the concept of symmetry. Symmetry in graphs, we talk of mirror image. Mirror image. So think of that word. When we say symmetry, not symmetry, I don't balance it now. Symmetry is basically an issue about mirror images. Now let's have a look. If this is the case for A, now we usually, when we use symmetry, try to use critical points like an x-intercept. Let's use the cosine graph because of symmetrical nature of what is going on in there. So if we just take this down or back into the x-axis and then we do the same for this one, you will appreciate the fact that, can you see, from that critical value to that point, it should be the same from that critical value to that point because I'm moving to the left. So if we're saying this graph is symmetrical, then this would mean however many units that this is, it should be the same as these units over there. Now we already are given that value. So from 90, we simply subtracted 7.37 degrees to get there. So that means we're going to do the same thing. So now let's say B is going to be basically 90 degrees minus, because this is subtracted. So whatever action we did, we do the same for symmetry. So this would be 7.37 degrees is to, now we look again, we see that this is below the x-axis and this is above the x-axis. But if these 2 points are to be mirror images, then we can see that we need to do a vertical shift. Not a vertical shift, sorry, but a vertical reflection of this point. So we'll just multiply this one by -1. Okay, maybe let's just say minus 0.38 times -1. So can you see this is more like a horizontal reflection, a horizontal translation to the left by these units, as well as a vertical reflection about the x-axis. Therefore, it gives us that point B would be, let's see, this is going to be 90 minus 7.37. This gives us 82.63 degrees is to the positive 0.38. Can you see? So just write it down. So B is going to be 82.63 degrees is to 0.38. All right. So think of this as a horizontal translation to the left by 7.37 units and vertical reflection of the y value about the x-axis. Okay, so this is how you can think of these things, and those concepts will help you because they give you mirror images. So these things you don't learn in paper 1 just for fun. You learn to apply these things even in issues like trigonometry. Okay guys, we get a mark for this. I don't know. We get a mark for this, and of course maybe the setup. I don't know how those 3 marks come about, because when the question says write down and you have 3 marks, it's ridiculous, because that's not how we ask. It should be 2 marks, because it's going to be 1 mark for this, 1 mark for that. just an answer only is okay. But why 3 marks, I cannot explain it, because you can't give 3 marks for a write down. 2 marks, yes. 1 mark, yes. 3 marks means we need to see a calculation. So maybe it would be best to say calculate or show how to obtain the coordinates of B. Maybe it's the fact that they would say, okay, if you got it right, you get a bonus mark. You know what? Examiners will do whatever they want, as long as it is not bad. Okay, let's move on. Well, to write down the period of G, remember now X, can you see this was a single angle, now it's triple, so that means the period is going to divide by this one. So period here is going to be 360 degrees divided by 3, the coefficient of X, which gives us 120 degrees. Again, we are writing down, so what do? We'll just write period is equal to 120 degrees, and that's it. So we're getting 2 marks for the answer. So 7.4 says now write down a value of X for which this is a maximum. Okay, meaning the greatest distance. So now how would you do this? Well, what I normally do, you can just take a ruler and target an area that you think is giving us that vibes. Maybe say this distance here, maybe. But make sure it's a vertical distance. Maybe that distance there. You don't know, right? Right. We're just trying to find something that works. And then maybe this one, let's make it different. Maybe that one, or anywhere else. Now what I do, if I used my ruler, you need to mark this on a paper. You can even use the question paper, or your answer sheet. Just tear off a small portion of that information sheet to use it as your ruler. Then you move whatever those marks you made, you move them across. Can you see? This is literally vertically bigger, even though this is slightly slanted. Can you see it's bigger than that? And it's bigger elsewhere. So this means this distance is bigger to the right. Let's go to the left. See, we're almost moving in the same, but then it starts getting bigger. So this is the same, then it gets bigger, smaller and smaller. Then if we move down to this one, it's bigger. Can you see it matches that distance almost? So this means the greatest distance between these two is literally over there or over there. Those are the identifiable points because there's an x coordinate of minus 180. There's an x coordinate of 0. Can you see? So that's how I would answer a question like that. Okay, so because sometimes you just need to look at it and like it. So what I often do, as I just showed you, I just take a page and place it across this point, and then I would mark on the page what corresponds with that and mark what corresponds with that. And then of course that would be a piece of paper. Now we're going to imagine this is that piece of paper. Can you see those dots move the same way? So if you move that paper from here, you move it across, you will see that that one is smaller. You move it this way, it looks okay, then it gets smaller. Then you can move it so that it fits here, you move it across, and then you can see it matches. So that would mean this is the best place to look, or that is the best place to look, mainly because we can see that here we have a value of x. This is what we are looking for. At the origin, we've got a value of x. So that's what we do. So we answer this question, but it says a value, not values. So we can just write here x is equal to minus 180 degrees. Or this is, you don't present this answer. Present only one answer. Always answer the question. Or one can say x must be equal to 0 degrees. At least those two. We can see that there is a portion here, but we don't know. We can't determine that. We leave it. So this is what we do, guys, to avoid unnecessary problems. For answering the question appropriately, we get 2 marks. And that's a total of 8 marks. Of course, guys, I'm doing this one in 20 minutes because I also want to take you through the thought process that you need to go through and exactly what works in what way and how to go about answering questions in the best way. Otherwise, I could easily just present these answers. I mean, that would be me trying to reproduce the memo as it is. But would you learn anything from it? Answer is no. So you need to understand the framework. At least know how to go around things. And obviously, this is just to say, if you're doing this for the first time, or this is the first time you see this, maybe it would be nice to understand at least, because you might find that this was your weak point. Then you go and get it right, get those extra marks, and get to that decent mark you are looking for. Okay, let's get to question 8 quickly. So question 8. What are we doing here? Well, we are given that sketched below is the graph of f, which is minus the log of x. Okay. And we can see this is a decreasing function passing through x equals 1. So what does this mean? This gives me the vibes that the inverse of f is such that y is equal to a half of x, because I know for a fact that if this is a decreasing function, its inverse will also be decreasing, doing stuff like this. Okay, so this is essentially what I would expect, but maybe let me do it better. Okay, it would be doing stuff like this. All right, passing through there. So this would be the f inverse. Okay, easy. And obviously we can appreciate what the equation would be. And some people would write y is equal to 2 to the exponent minus x. But negative exponents by law are not sightly. This is like being dirty. Or bubuqele kunje maths. That's why we don't leave denominators irrational. We also don't like this because they confuse you in terms of determining the direction that this takes. But when it is like this, it's easier because we will appreciate that now if whatever x value we put in there, we can tell what is going to happen to this expression, right? Right. But when it is like this, you are not so sure what on earth is going to go down here. When are we decreasing? When are we increasing? It's not easy. But this one is easy to tell because, you know, once the base of the exponent, the base of that power is less than a half, that means whatever exponent value you choose, it would decrease like that. So always try to simplify algebraic expressions so that you can have a sense of what direction they take. Because there are certain things you need to solve by inspection. There are certain things that may force you to do a proper calculation, or just apply a law and you will have a direction. Great. So this is what you do mostly because inverses are usually heavily applied here. That's why I'm already jumping into an inverse function, because I know with this question, usually inverses are going to hit you. Even with straight lines, inverses are usually there. All right, hardly would you see inverses on the parabola, but be able to do it if it comes. All right, okay, all right. Sorry. Now let's just answer the questions nicely. It says write down the domain of f. Now we can see the graph of f doesn't intersect this vertical line. Of course, a logarithmic graph will always have a vertical asymptote, whether shifted or not, but it will have it. So we can see this graph is all the x values greater than 0. Okay, so we can just write here 8.1. We can just say here x must be greater than 0. That's it. Don't even complicate a simple question. So 8.2 says write down the equation of the inverse. Can you see we've already sorted it? So we can say, well, the inverse, okay, let's just write according to the prescription. It says y equals, so we can say y is equal to a half to the exponent x. Of course, one can present it like that. It's not a big deal. So we get another 1 mark. Can you see? Because this is something you can do by inspection. No need to do a whole lot of work. 8.3. We need to write down the equation of the asymptote of the inverse. Can you see? There is the inverse. We've already done it, and the asymptote becomes the x-axis because that one was the asymptote. So if we have, for example, a vertical asymptote on the original, then we will have a horizontal asymptote on the inverse and vice versa. So we can just write y is equal to 0. Be very careful. The x-axis is actually the line equal to 0. And the y-axis themselves are the line x is equal to 0. So be very careful when you have to do this. Don't write, unless you write the x-axis. I don't know if you wrote it that way, what would happen. But the question said equation. So if you have to write an equation, you need to know this. In fact, I think that settles the problem. You just need to respond. This is an equation. The x-axis is just a description. Okay, great. So 8.4. It says explain how using the graph of f. Can you see someone is dictating how we're going to answer these questions? So if we don't pay attention to this, then we are dead. And this would be a higher order question because a standard grader would not know what's cooking here. Now, can you see how using the graph of f would you sketch? Now, what are we trying to do? We want to sketch the graphs off. Now, that means if these things, we can actually use this graph. It means these could be transformations of f, okay? Now, a transformation can be a reflection. Now, as you know, with reflections, we've got vertical reflections. I'll just say VR. We can have horizontal reflections, HR, and we can also have inverses. Okay? But technically, a reflection can be about any given line. Sometimes when it is not a vertical or a horizontal or an inverse reflection, so to speak, it becomes what would constitute a rotation, so to speak. And you learn these in grade 9, guys. So be very careful. Reflections can also cause chaos if you don't appreciate them. Now, any other form of transformation could be a translation. Oh, my tablet needs to be charged. A translation. Remember, with translations, we can have a vertical translation, I'll just say VT, or a horizontal translation, HT. And you can say this is left or right. This could be, sorry, not left or right, but up or down. Or it could be left or right. Okay? Be very comfortable with these kinds of transformations. So this means we can show up here if we're doing transformations of the function f. Because for us to use this graph, it means we need to relate this as mirror images of f, so to speak. Can you see? Again, it goes back to that word of symmetry that we just spoke about. So essentially, guys, once you understand the framework of the question, it becomes a very easy breeze, you know, to just go and enjoy on the shore side or seaside, whatever it is you call it. But you see now, simplifying things by using a bit of theoretical knowledge, because this is where you get challenged. It's when you have to integrate. And this one is not being volunteered, just write the transformation about. Now this forces you to think of it, find it, and then respond to the question. Now let's look at this one. G of x is the log of x to the base 2. What was the function f? Can you see? Log of x to the base 2, but negative. Now this one is positive. What did we do? We simply multiplied that by a negative. And when we multiply the entire function by a negative, what are we doing? A vertical reflection. Now, a vertical reflection is basically about the x-axis. Remember that. So this means we are vertically reflecting the graph of f to obtain the graph of g. So the question said we need to explain, meaning we need to speak about this transformation. So we can say we would sketch G by vertically reflecting reflecting the graph of f. Or sometimes you may want to use this one about x-axis. Right. Yes. So this is your option. You can say we would sketch the graph of G by reflecting. This time you eliminate this word. You'll just say by reflecting the graph of f about the x-axis. Or you can just simply say we would sketch G by reflecting the graph of f. Easy, ne? That's very easy. So please guys, do not flinch here. It's easy stuff. Okay, so now I'm not answering the question. I'm just writing gibberish. Okay, now let's make sense. Be careful guys to answer questions appropriately, and as the instructions dictate, please number things according to the pattern used. Now we see H is this thing. What did we see? Can you see? Is the inverse. So not inverse. So can you see this is an inverse of f? Okay, but what happened? We translated it down. That was a vertical translation by 5 units. So this is a reflection first, then a translation. But can you see which one carries more marks, do you think? It's a transformation into a slightly different function. That would be a reflection. Because when we translate the same final product. Okay? So this is what this is. So we can say sketch H by reflecting. Remember, an inverse is a reflection. By reflecting f about line y equals x, and then translate 5 units. Oops. Down. Nice. Because of course the question was, how would we sketch these graphs? We would sketch them by literally just reflecting this one about the inverse line. What is that line? This is when we draw this one, and of course that would be the inverse line. Sankaela wena man. Sikantlwaela man. Akina nako, abona. Mpetha ka nako bjano. This is the line of reflection. As you can see, these ones would be equal here, because here x and y are the same, and it would be the same value whatever those areas are. And about this line, these would make up inverses. Okay, great. It is interesting, if not interesting. So can you see guys, first of all, knowing the reflection and the line of reflection becomes the special thing now, because it's not just any other reflection but about a specific line. Okay, and essentially the 5 units down. You can say shift if you don't like the word translate. And then they shifted down 5 units, not S. Yeah. But to 5 one game because anyway, so now that is the one. I hope you guys are happy there. Now let's just get those 3 marks and smile ourselves forward. So 8.5. Now it says use the graph of f again to solve. What do you understand by the word solve? More like a calculation, right? more like the word calculate. Remember in paper 1, what do you get in question 1? Solve for x, and how do you do it? So we can accept that whenever a question says solve, more like a determination, but trying to force you into a form of a calculation, Yes, you can perform a minor calculation that you can later use inspection, because you need to bring us something that is visible. Then you can make an inspection and a deduction. Then we can accept. But if there's no little bit of a calculation, then it means you're not doing what you're being asked. So again, mathematical language becomes a key factor in these kinds of exams. But again, guys, you will not appreciate this if you just practice by rushing through these questions. But if you spend a bit of time, you'll start to understand that there's nothing difficult in this subject. Yes, it's not a walk in the park. It's a challenging subject. But you can create an ease of every difficult position in this subject by ensuring that you've got the right basics in the right place, and you are able to use them in a flexible manner. Anyway, I would explain until Jesus comes. Let's just answer this question. So what are we doing here? We want to use the graph of f to solve, meaning some form of a calculation, to solve for x, where this graph is essentially less than 0. But now what is this graph? Can you see this is the same graph as that one? So what is that graph? We explained this, that this is a vertical reflection of our original function. So now we need to take this equation, because we need to show some calculation of some sort. We can just say log of x to the base 2. This is how you read this. You first say log of a number to a particular base. This is why we call it an inverse of an exponential, because with the exponential, you start by naming the base to an exponent. But this time you start with what would be an exponent, so to speak, and it's not really the exponent, but it's the number. It's actually the answer. Then this would be the answer when you take this base to a particular exponent. Can you see? But yeah, this is more like the story, because the x becomes the exponent, the base becomes the base. So what do we say? Log of a number to a base, not log of a base to a number. No, log of a number to a base. So this is how you read. You read like this, like that. With exponents, you start here, or exponential expressions, you start with the base, you go to the exponent. Okay? Yebo, 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 yebo. Yes. Anyway, guys, this is just me trying to be overzealous. Otherwise, is it all necessary? No. Maybe. Maybe not. You decide. Now, what are we doing here? We've got log of x to the base 2 less than 3. How would we transform this into the function in the screenshot? And then we ends up in the move and the screen, and then you bet screenshot land. Anyway, nansi ya lento ngoku sizayitshintsha kanjani lento, because ithe into masisebenzise umzobo kabani ka-f. Ngoku ayingo-f lo, into ethi ke ngoku kufuneka sitshintshe lento ibe ngu-f kuqala. Emveni koko into ezawusala apho siyiphendule. Le nto sizayiphendula ngoku ka-f, asizuyiphendula directly, because we know that the vertical reflection of f is going to do stuff like this, basically. This would be the graph. Okay, masizame futhi ngathi impi. Okay, if ibonakala nje, okay, maske si-shift kancinci ngathi funa ngiqhela kabi. Azombani somana ucinywa apha. Yho, yena wacima ngexesha elibi, guys. Yo. Hayi, wacima ngexesha elibi. Ndingagqibanga nokwenza into zam la. Yo. Ndisengxakini. Anyway, folks, sizayikhatha la le video, because I don't think linear programming you guys need it, but I will try and see, but it's out deteriorate fast. Now, folks, we know that we just multiply this by -1 because we are showing what we did. So this is going to be minus the log of x to the base 2. Now, when you multiply by negative, the sign changes and that one changes. What did we do? We performed a calculation. This is a calculation. We get a mark for this. Now we are saying, when is the graph of f greater than -3? Can you see? Nanku -3. So ingathi dibana naye phaya u8 ndiyijongile ingathi ihlangana no8 yabo, sort of ingathi nje. So can you see? That is the story. So we can say, therefore, x must be less than 8 because we're saying greater than. Remember, these values are greater than -3, then greater than 0 because it cannot be 0. Now that is the last 2 marks. So we get a total of 3 marks. All right, folks, I don't know how long this is going to last here, but I think it is on challenge because I don't know if I'll be able to answer the last question fast. Ibhetri lam lingacimanga to 0, so maske sibone, this is going to be what? 10 marks. Okay, you can appreciate that, guys, understanding things. So this is minus f of x, basically. All right, a vertical reflection of f. Now, we can appreciate that if you know and you understand things, this becomes a walk in a park. But of course, understanding what the question is dictating, because this step is key. If you don't perform that calculation, then you can't use f. So we need to try and put it into the framework of f first. Then we look at it. Obviously, somebody may even perform a calculation, but I mean, if you are good at what you're doing, you just know how to do this. I mean, you can even show this as dotted lines to show that this is what you did. Because if you draw a horizontal line and then they intersect like that, then you know you're good. But at the same time, you may want to know, maybe when is this log of x equal to 3 or -3, for example. You can just solve for that in case you're not sure. Just make this one equal to, just say log of x to the base 2 equal to 3. Then you change to exponents. This is going to be base 2 to the exponent 3. That is 8. Can you see? But I mean, if you are comfortable with this, you will already know this is the case. You don't need to even sweat. Once it looks like it, and you know at the back of your mind, this is what you do, then you know this value is going to be 8. You can even show this calculation. It's okay. But when they're telling us to use the graph, any means necessary though, guys, must answer the question, okay? Good. So let's move on. Somebody asked for question 13. Now you can see this is linear programming. So I don't know if you guys do this section, but maybe you might be in a curriculum or some program that actually does use this. Let's see if I cannot rush through this question within this moment I have left. Because you see my battery now is 10%, and you see not charging it was a bad idea because now the power just went off and I can't charge it anymore. I don't have the power bank. I'm a very backward person, if you ask me. Now, it says a steel manufacturer makes 2 kinds. Usually you get this. You get 2 things to think about. 2 kinds of products, A and B. Nice. Now, having parts that must be cut, assembled, and finished, okay, whatever. The manufacturer is aware that it can sell as many products as possible, okay? Now, many meaning the minimum, meaning from whatever value and more. So think of greater and equal to some variable, because this can be any value, which would be the starting point, and anything above it. So as many as possible. This means more or less, right? Right. As it can produce. Great. Now let x and y be the number of units of product A, meaning x goes with A, and then B would go with Y. So again, understand the framework of the question. All right, that are manufactured every day respectively. Again, every day. Just know the time or frequency in which this is done. Now, the constraints that govern the manufacture of the products of the products are represented below, and the feasible region is shaded. Again, usually in your prelims during our time, you would get to draw this because it would be given statements enough for you to first find the constraints and then draw them on the graph, as I highlighted before. But in the finals, it was nice in that you would be given the graph, then you have to use the graph and the piece of information provided. And as we can see that we shaded to the side of the y-axis. Okay, let me just use one arrow. Can you see of the y-axis we shaded to this side? So what does that mean? What is this? This is defined by x, because remember y-axis is the line x equal to 0. So we can just say x is greater than or equal to 0 because it's a solid line. Once you see a solid line, it means that is included. But if you see a dotted line and you are shading to this side, it means x is greater than 0. Dotted meaning not included. So again, pay attention to the notations provided. Okay, I don't know how long this is going to last. And then again, we shaded above the x-axis. So that means this is a solid line, as you can see. This means y is greater than or equal to 0 because the x-axis are the line y equal to 0, right? So be careful of that. Nice and easy. So this is the story. So we can already see that these are the constraints in this thing. And then we see again this line. It's going all the way to 18 and 6. And we know to get the gradient, we would take that and divide by that because this is from the origin. Origin is 0. Okay? So 6 divided by 18, that's a third, but this is a negative gradient. So this is suggesting that y is equal to minus a third of x. Now the y-intercept of this line is going to be 6 as it is, plus 6. But remember, we shaded to which direction? Below that line. So this means this is less than or equal to that line because it's a solid line. See? But now remember, when we write these constraints, we normally don't really leave it like this. So the best way to write it is to just transpose this side to that side, okay? So because remember we said product A and product B, numbers of which we then multiply by this. If we multiply throughout, what do we get? We get 3y less than or equal to minus x plus 6. 6 by 3 is 18. Now we normally transpose because we're producing two things, so they must add together. So we can say 3x, we transpose this, we can easily say this is x plus 3y less than or equal to 18. This is the best way to write it, but again, that is not incorrect. So this equation here, we can see that this is x plus 3y less than or equal to 18. Nice and easy. All right, what else can we say? We will see that this particular line, we shaded to that side. Again, this is 8 and 8, so the gradient is minus 1. So here we will have y equals minus x plus the y-intercept is 8. Now obviously we shaded below that, then that means less than or equal to. Therefore, we can say x plus y is less than or equal to 8. Okay, that's the constraint. This is the best one for this one. So we can write this one, x plus y less than or equal to 8. And then the last one. We can see that this line here was shaded to this side. And what do we see there? We see 14 and 7. So change in y over change in x. So this is minus 14 divided by 7. That would be minus 2. So this means y is equal to minus 2x plus the y-intercept is 14. Then we just see that we shaded below this line. So this means less than or equal to. Therefore, we can say 2x plus y is less than or equal to 14. So that is essentially how we write those constraints. So this is the line. 2x plus y less than or equal to 14. So usually, guys, these are mark worthy because finding these constraints is key. So can you see? Very, 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 very interesting stuff. So I hope you understand exactly all the procedures I performed here, because if you don't get them, you will be in trouble. Ne? So it's a must to get them right. Now let's just answer these questions within these remaining minutes quickly so that we can see if we can't make it. Write down the constraints in terms of x and y that represent the above information. Can you see? We can write here x must be greater than or equal to 0, y must be greater than or equal to 0. We can say 2x plus y must be less than or equal to 14. We can say here x plus 3y must be less than or equal to 18. And then we have x plus y must be less than or equal to 8. Is that all? How many are they? 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. So 7 marks. I would say maybe 2 marks for each of these because they're a bit complex, right? 6 marks. These ones are too simple. We can give 1 mark and say this is the total of 7 marks. Okay. So 13.2. It says now if product A yields a profit of 30 rands per item and product B yields 40 rands per item, write an equation indicating the daily profit. This is easy. Profit is going to be 30 times x plus 40 times y. That's all. Easy, 2 marks. This could be easily 1 mark. Now, determine the number of units. See, we want the number of units of product A and product B that needs to, that the manufacturer needs to produce in order to maximize the daily profit. Okay, so now what we do here, so 13.3, what we often do is just solve for y in this equation. So we transform that equation, this one. We need to define it in terms of y. So we'll see that y is going to be equal to minus 30 over 40. This is going to be minus 3 over 4 x plus the profit over 40. Okay, this is the best way to do this. Now once we do that, what are we interested in the gradient? So we just go to the graph and draw any gradient that matches this. Minus 3 over 4, that would mean this could be 3 going to 4. Right. And then this is what you draw. You draw a line here with a ruler, a dotted line usually. And then we steal that line. We steal that line and put it over there. So when you move it into the corners, remember you try the corners. It can't be maximum here. But can you see when you put it here, it must not go into the feasible region. We put it there, it cannot go into the feasible region. But when we place it here, can you see it does not go into the feasible region, but here it does. So that would be the area for maximum. So this is what you do with linear programming. Then of course this must be in dotted line. Okay, and then of course we still represent this because you are usually provided a graph for this. Okay, so you just show that these lines are parallel. Sometimes you can even indicate that those lines must be parallel, and therefore this is at this corner where we do that. And then of course you just read on the graph. If you just go straight down, you will see that we're going to 3, and then if we read straight across, you will see that we're going to exactly those values. And if you're not sure what are you going to do? You take this equation, because that's that line, and then you take this equation, that's that line, you solve simultaneously. They will give you those coordinates, and those coordinates is what we are looking for. But I mean, looking at the graph, it's quite easy to see what's cooking. So we can just simply say, fine, what do we see? We must have 3 of x and 5 of y. So it says the number of atoms, we can just say x must be equal to 3 and y must be equal to 5. Okay, or maybe you can just say 3 of x it says how many? Okay, 3 units of A and 5 units of B. Great. So of course you will have shown how to do this on the graph. You can even indicate C graph because it is provided. Usually we use the graph to do this. So for showing us that gradient and showing us exactly where the maximum is and then reading off those values, that's usually 3 marks, but we're only getting 2 marks, meaning the technique is not being rewarded, but the actual answer. Okay, nice and easy. Okay, let's do the last question quickly. It says now the manufacturer would like the maximum profit to be at 6 and 2. So what does that mean? Where is that? So there is 6 and 2. So slangana pa. So this is the point. Now at 6 and 2, okay. So now at 6 and 2, remember this thing, if we're maximizing here, we cannot enter into the feasible region with our maximum line, whatever you call it. So this means the line needs to at least be this. Can you see this gradient? See this gradient of that line. And the gradient of this line. Okay, maybe, I don't know. What can I choose? Maybe let's choose that. Can you see the gradient of this line? It means we are looking for a gradient that is in between these lines. Right? Right. And the good thing is that this line, can you see, it doesn't enter the feasible region. So it means it could be this line. It could be equal to this gradient. And we can see that this line also does not enter the feasible region. So it means it could be this line or any line in between, like the one we just drew. Can you see? So how do we do that? We know the gradients of the other lines. So this would be more like a range between that. So 13.4 would say the gradient, because again, I didn't read the correct. So the profit given by this equation says determine the values of m for which this will satisfy the condition. Okay, says guys. Now you can see that this is between these two gradients, right? And they are included. So we can see this is the biggest because the less negative is bigger than the more negative. So we'll start with the big one and say m must be less than or equal to. Now what is the gradient of this line? See, this is minus 1. Ne? So this is minus 1. And then greater than or equal to this one, you can see the gradient came out as minus 2. So we can say minus 2. And that's it. We get those marks nicely. Okay guys, again, I won't spend a lot of time and explain. So this would be the 13 marks here. And you can see it's not that bad, eh? Linear programming is all about knowing the actions that are necessary to do. Then you answer the questions. And sometimes it gets challenging because you're getting the range of gradients here that need to maximize at that point. But remember, the key is that whatever line you choose must not enter the feasible region. It can sit on the borders, yes, or at least just touch a point on that. Okay guys, I hope you enjoyed the video. Let me cut it here before my tablet goes off on its own. I'll see you some other time. Goodbye and good luck.